I know you already had previous discussions about synchronous machine in EE360 course. Okay, I will not depend.
Victor, are you sharing the slides?
Is it shared now or not yet? Okay, sorry. Is it clear now?
Yes.
Yes.
Okay.
No, doctor, it's not clear. Oh, it's clear now.
Okay. Fine. I know you already learned about the synchronous machine before in EE360. However, we will refresh your knowledge again and continue discussing the topics which have not been covered in EE360, which I think it's very important in industry and in general for synchronous machine. Right. So this is the objective.
Sorry for the interruption. Can you display the screen for the full screen? It's better.
It's full now. Is it not full?
No. Can you? There is
which
a
screen you see? Two screens you see now? Sorry. You can see full screen now, right?
Yes.
Okay.
Yes.
So this is the general objectives, شباب, of this, not this class, of this file. Okay, I will share it with you after the class, inshallah. But we will cover some of the beginning topics here regarding synchronous machine. So we will discuss the different types of synchronous machine, the construction of synchronous machine, recognize the synchronization conditions, and what is the meaning of synchronization conditions, determine the synchronous reactance, drive the phasor diagram of synchronous machine at different power factor cases. And I wish we can cover this part, inshallah, today. Firstly, Shabab, I know all of you know that the synchronous machine, the rotating one, because we have linear motor or linear machine and rotating machine. For the rotating machine, I know that all of you are familiar with the construction. We mainly have two parts, Shabab, stator and rotor. These are the mechanical parts. Okay, for the stator, the mechanical part of the stator is the stator core itself. It's made of a laminated sheet of steel, and it's made in lamination to reduce the core losses of the machine. Okay, and on the stator we add the three-phase windings. So the synchronous machine is an AC machine. We are going to discuss the three-phase. طبعا we have, شباب, multi-phase machines. We can have single-phase machine. We can have two-phase machine, three-phase machine, and so on, multi-phase machines. We have now in the market 5- and 6-phase machines. However, the most well-known and used in industry is the three-phase one, which is used a lot in our industry. But for critical loads, like in submarines, we need multi-phase machine because of the reliability is very high for multi-phase machines. But for now, for this level in this course, we are going to discuss only three-phase machines. So for the three-phase machine of synchronous, we have three windings. Each winding represents one phase, and these three phases are wound on the stator structure, which has electrical, the windings have electrical phase shift of 120 degrees, okay? Because in three-phase system, we need phase shift of 120 degrees. So the windings are wound on the rotor such that having 120 degree electrical phase shift. This is for the stator. It's conventional stator, Shabab. For the rotor, we have rotor of two different shapes. As you can see here, this is called cylindrical type, and this is called salient ball type. Inshallah, in this course, we are going to discuss all of these types according to the difference between them, the mathematical models, the application type. For the different types شباب. We have field winding which are wound around this rotor. What is the reason of having field winding here? The reason is that we need to establish flux in this machine. You know يا شباب, we cannot convert electrical power to mechanical or mechanical to electrical without field. Is this right? Do you agree with me يا شباب?
Yes.
Yeah.
Yes.
Okay. So
Yes.
we have to have field winding in the machine in order to convert electrical power to mechanical power and operate the machine as a motor, or converting mechanical power to electrical power and operate the machine as a generator. So the same machine can work as a motor or generator. It depends on the power flow direction. So the same machine, it can be operated as motor for certain conditions if the electrical power is the input, and it also can operate as a generator if the mechanical power is the input of the machine. Type. So now we have two different shapes of the rotor. Which one we should use in the applications, according to the applications? We can see that this cylindrical rotor, the cylindrical rotor is used with high-speed machines. High-speed machines, normally the number of poles are small, 2, 4, 6, like that. Okay, and in this type of rotor, يا شباب, the diameter of rotor is small. Okay, the diameter of the rotor itself is small, and this can be used for high-speed turbines. Now we will discuss mainly, or we are going to focus our discussions on synchronous generator, because it's the majority now in our industry. All or most of electrical generators in power stations are synchronous generators. So in most of our discussion, we will refer to the operation mode as a generator. So we can use synchronous machine as a generator for high speed. Okay, we can use the cylindrical type because, as we discussed, the number of poles are small, and there is a relation between number of poles and the speed. We will drive it now. And the diameter in this case, because number of poles are small, the diameter will be small. However, the rotor will be long. So this length will be long, and this diameter will be small compared to the cylindrical type. Compared to salient pole type. The other type is the salient pole. The word salient, شباب, means that the air gap between stator and rotor is not uniform. Yeah, if we let me draw small thing here. Again, the display is a problem. Yeah. If we have a شباب stator like that, this is one section of the stator, and inside here we have the rotor like that, you will find that the air gap is uniform. Okay, this is called the cylindrical type. This is the first type. For the salient pole, the rotor itself may be like that. If we have two poles only on the rotor, it will be like that. So if we have stator, so the air gap here is not similar to the air gap here. Is it right, شباب? For that, we call this as salient, because the air gap is not uniform between the stator and rotor core. So this is the reason why we call it as salient pole, because of the saliency of the rotor structure. Type. This rotor structure, شباب, is used when the number of poles are very high. طبعا here number of poles are small, just to represent or to be shown in the figure. However, in reality, number of poles for this machine can reach to 70 poles. 70 poles. And in this case, شباب, the diameter will be very high, may be reached to 15 meters, 15 meter, 1.5. Okay, this is the diameter of the rotor. Okay, and the length of the rotor, which is this length, is smaller compared to the cylindrical one. And this type of machines is preferred to use with low speeds, several tens or hundreds of megawatt hydraulic turbines. This is the application, the main application for salient pole machines. Okay, شباب? Is there any question regarding this part? Is it clear?
Doctor,
تفضل.
you said that the diameter in the cylindrical is low?
Yes.
Like
Around 2-3 meters maximum.
Oh, okay. That's maximum.
Yes, yes.
Okay.
Okay. Fine. So this is just brief comparison between the different structures of these synchronous machine. Excitation systems. What is the meaning of excitation? Excitation,
Doctor.
Yes?
Someone raised his hand.
Yeah, please, if you don't raise your hand, just ask immediately.
Sorry, Doctor, I wanted to ask about the silent motor application. We use it.
Salient motor, yeah.
Salient motor.
It's rarely used as a motor, but generally used as a generator, as we discussed. The application is low speed. For instance, we have here the high speed, like in gas turbines, like in steam turbines. Okay. However, low speed, like in hydraulic turbines, like in wind turbines. Okay, the speed is small, so we can use the high number of poles in order to attain the required frequency. Okay, and I will discuss, inshallah, the relation between speed and the frequency, and it will be recognized. But for the application now, we have to understand that salient pole is preferred for low speed applications, and the cylindrical type is used for high speed applications. Actually, most of generators here in Saudi Arabia, maybe more than 90%, will be cylindrical type. Rarely you can find salient pole here because no wind energy are provided now in the kingdom, and also the hydro turbines are also not there. So you can find very few salient pools here in Saudi Arabia. However, by the penetration of renewable energy شباب in our grid, you may find this type of generators soon, inshallah. Regarding excitation, excitation means to establish the magnetic flux in the machine. We agreed together that you cannot convert electrical to mechanical or mechanical to electrical power without the help of flux. تمام يا شباب؟ طيب, in order to do that, we need to make a source for excitation. Now we discussed that we have 3 phases on the stator, which are called armature winding. All of time يا شباب, the armature windings are the power winding, the windings which carry the power of the machine. The other windings are called field winding. So the excitation means here to supply the field winding in order to establish the flux in machine. Or if the machine has no field winding, it will have its own permanent magnets. So we can find in synchronous machine, we have permanent magnet synchronous machine or field winding supplied by a DC source. And the required source for field winding here is DC. So we have 3 different types, either having permanent magnet generator, and it's rarely found in industry because permanent magnets are not preferred for this high power. Because in generators and power stations, you may find a turbine or generator of around 300 megawatt or megavolt ampere. It's not easy to establish this flux using permanent magnets. Or if you could find permanent magnets, it will be built in many steps, not in one step. And this is also a headache. Having permanent magnet for such high power rating is a very big problem. So we do not prefer permanent magnet generators in high power. High power, I mean the power in plants, in power plants or power stations. However, you may find it in a small diesel with generator. You can find it easily, permanent magnet, because you are not going to bring another source as a DC source in order to operate a generator. This is logic. Okay, شباب? So for a small diesel, okay, diesel is working by fuel. It can include permanent magnet synchronous generator in order to avoid the connection with the external DC source. So this is logic. But for high power applications, it's not preferred to use permanent magnets as a generator. So we have now two different ways in order to connect the field winding by DC source. We agreed together now the field winding exist on the rotor surface. And the rotor is moving all of time. Is it right? So in order to connect the field winding with DC supply, we have two different methods. Either using brushes in order to connect the moving parts, so we need brushes, or using another technique called brushless excitation. And this is the most preferred. But both of them exist a lot in our industry and in power generation. A lot of generators are using brush excitation. However, the most preferable is the brushless excitation. Why? Because brushes needs maintenance all of time. You have to check the brushes all of time. Otherwise, it may make accident. You know, the brush. What is the brush shape, Do you know?
I think it's made by carbon.
Yes, it's made by carbon, exactly. But the function of brush, let me just draw small figure here. For instance, this is the rotor structure. And in the rotor structure, we have here, this is the shaft. And assume we have one ring here, which will connect the terminal of positive, and another ring here, which will connect the terminal of negative. Okay, شباب? So the brush is nothing but a spring which pressing a carbon brush here to this ring in order to connect this negative part to outside. And you will have another ring here by the same way, spring with the brush. If this brush, شباب, is how to call it, by friction, it's finished, okay, حصل لها تآكل, okay, what will happen? This spring will be in touch with what? With the slip ring itself. صح يا شباب؟ طيب, if you have two metals together and with external force, what will happen? With the rotation, طبعا it will make a problem or may damage the ring itself, okay, and may make sparks. طبعا this spark in high power may cause a very big problem, may cause a short circuit between two windings, and in this case, it will be very dangerous. For that, we have to check the brushes all of time. طبعا there is a periodical maintenance, okay, two different maintenance, one every several months, and one is made by year in order to check all of the machine parts. However, brushes need the periodical maintenance, need to have checked to the brushes all of time. So this is the drawback of a brush system. طبعا يا شباب, we here just represent two brushes. However, in reality, you will have, for instance, 36 brush for positive and another 36 for negative. What is the reason of having this high number of brushes? The reason is that if you miss one of the brushes, the other brushes will still connecting the system. However, even if you miss one of the brushes or the carbon is finished, it will make also a problem because of the spark. Okay, so we have to check it all of time. طيب, this is for the
Sorry,
brush.
doctor.
تفضل.
Actually, the purpose of this brush just to start the motor.
No.
Because I saw in some DC motors, especially they use the brush for the, I don't know, but I think maybe for starting. I don't know. This is just my doubt.
No. Brushes are not for starting, even in DC motor. Brushes are to connect the terminals to a rotating part. This is the aim of any brush. Because if you have rotating elements, how you can connect a fixed wire? It's not possible. صح ولا غلط? Because the wire will be cut. مظبوط?
Sure, yes.
So we have to find another method. The method is a brush. So this is the way how we can connect rotating winding. So this is the aim of brush. However, is it going to help the motor to start or not? This is another thing. And even in the DC motor, the brushes are not for restarting. Brushes for DC motor is used to connect the armature winding. Inshallah, we will discuss also DC machine in our course, and we will elaborate more in the operation of DC motors and the control, inshallah. But for now, here, brushes are used to connect the field winding, not the armature winding, because the armature winding are already on the stator side. Okay? This is the first technique, يا شباب, which is brush excitation. And we now got the idea what the brush are doing and what are the drawbacks of using brushes. Regarding brushless excitation, which is preferred, let's see together this scheme of brushless excitation. If you can imagine now with me, we have two parts of generator. We have stator and rotor. So here, this is the synchronous machine. This part represents the moving part, which is the rotor, and this part here is the stator. So we have here 3 windings of the stator, and we have 1 winding for field, which should be connected to a DC supply. How we can connect a DC supply here to the moving windings without using brushes? This is the aim of brushless excitation. If we have another machine, يا شباب, like DC generator, here we have 3-phase rectifier. This is, شباب, is nothing but converting AC to DC, okay? And after conversion from AC to DC, this will supply the stator windings of this machine. So we have here stator winding, which is the field winding of a DC motor, sorry, DC generator, okay, and DC machine. So this is here representing the field winding of a DC machine. And the armature of DC machine, we know that the armature of DC machine is both on the rotor side. So here we have the armature windings of the DC generator. However, the machine of exciter is different a bit compared to the DC machine. What is the difference? You know, in DC motors or DC generator, DC machine in general, we have one part called commutator. This commutator is nothing but cylinder made of, for simplicity, 2 halves only, just 2 half cylinders, and these cylinders are connected to brushes in order to convert AC to DC. So this is the main purpose of commutator in DC machines. However, the machine we have using here, which is exciter, this exciter, شباب, has no commutator. It's only the windings here are connected to another rectifier. This rectifier will convert the AC output of the exciter armature winding to be converted to DC. And for now, يا شباب, all of this part is rotating. So by this way, we avoid using brushes to connect the field winding here. ها يا شباب, is it clear or not? Is it clear يا شباب?
Could you repeat
Shall I?
it?
That clear.
Oh, okay, I will repeat. Okay, again, I will repeat. Again, يا شباب, the shape here, the figure, we divided in many parts. The lower part here representing the fixed parts, which are not moving. The upper part here, above this line, is the rotating parts. Rotating parts means we have here a shaft, and this shaft includes many rotors. One rotor is for the synchronous machine, and another rotor for the exciter. And we have also a three-phase rectifier, or general rectifier, also fixed on the rotor body, so it will rotate with the machine. Firstly, we supply AC to a rectifier here in order to convert it to DC. This DC field winding will generate AC EMF on the rotating windings here, because we have DC and we have rotation. Because of rotation, you will have AC generated voltage here, induced EMF يا شباب. So the AC voltage here will be generated and then rectified by means of rectifier again to be converted to DC, which will be coupled directly to the field winding of the synchronous machine. So by this way, we transferred the power here from exciter stator part to the armature part without any connection, just by induction, and converting AC to DC by means of rectifier. So for this way, شباب, we did not use any brushes. تمام يا شباب? Any question? طيب. This first, تفضل.
So, doctor, the thing that's responsible for rotation is the exciter field, is right?
Sorry, again, your question.
The one that created the rotation was the exciter field.
No. Rotation is coming by prime mover. This is generator. Generator, it means the generator is driven by a turbine. There is a mechanical device which is moving our machine.
Oh, okay.
Okay. The aim here of the exciter is only to produce DC supply for the main field winding. Okay. So here, this is a generator, يا شباب. We don't need to start rotation. Rotation is already coming by a prime mover. تمام? Is it clear now?
Okay.
Sorry, I have a doubt, doctor. What is the purpose for the DC source here?
Which DC source you mean? This part or where?
Yeah, at the end we wanted to give a DC source to the synchronous machine. Am I right?
Yes. What is the purpose of that? Is this your question?
This is my doubt. Yes.
Okay. We need DC to establish the flux. Okay. يعني let me يعني discuss it in a separate or even here. You have rotor like that, and you have stator winding. Assume this is the stator winding we have here. This is the rotor, and in the center of the rotor, this is a shaft. Shaft is moving by means of prime mover. If there will be any EMF produced here, this is just rotor without any electricity or poles or anything, and just rotating inside the stator. If there will be an EMF here?
Sure, no.
No, because there is no flux. However, if we establish a flux, constant flux, by means of connecting DC like that, so the poles will be created here like N and S like that, and it's already moving by means of prime mover. Is it right?
Yes.
So for this phase now, assume this is phase number A, for a certain period, it will see pool N moving, okay, يعني far and then come to the winding and far again. So the magnitude of flux will be changed. This is going to make EMF increasing and then decreasing again, okay? And when you reverse the polarity of poles here to be S, it will act the same in the negative half cycle. So we could generate AC supply, which is the main target of the generator. So without connecting DC field on the rotor circuit, you cannot establish any flux. So this is the main purpose of excitation. Okay?
Okay, I have a small question regarding this. How can, if we want to imagine it as a motor?
As a motor. طب يعني let's discuss this later, because we will discuss in details the motor operation and the problem of starting of motor operation, because we already have a problem with this machine. Maybe inshallah by next class. But for now, let's focus on the operation of the generator. Inshallah, we will discuss in detail the motor operation. Okay?
Okay, clear.
Another way, شباب, for brushless excitation compared to previous one, as you can see, we have here the synchronous machine, rotating rectifier, excitation or exciter, okay? And this exciter needs supply here, three-phase supply to be connected to this rectifier in order to supply the field winding of the exciter. Type. In order to operate this system, we need three-phase supply. We need AC supply, is it right? What about having self-induced supply? So if we have this shape, we have here some permanent magnets fixed on the rotor, and these permanent magnets, when rotating by means of prime mover, it will generate EMF on this stator. صح يا شباب? The same idea like generator, like what we have discussed here. Here you have poles, okay, and these poles are rotating, it will generate electricity. مظبوط يا شباب? So here, by means of permanent magnets, and these permanent magnets are fixed on the rotor side, so it will rotate and generate induced voltage on this pilot exciter armature winding. After that, we can take this three-phase supply and convert it by means of rectifier and continue making the excitation procedure. So the difference between this system and the previous one, here we don't need external supply because we generated the supply by means of using permanent magnets. So here we have pilot exciter, and the synchronous machine. Okay يا شباب, this method also is preferred. Like one question here يا شباب, and let's see your opinion here. We generate AC supply in order to generate finally AC supply again. Is it logic? يا شباب. Now we generated AC supply here on this stator windings. صح? Why we do not use it as output of generator? Why we need to do all of this, okay, in order to generate here also three-phase supply?
I think the amount of the output of the generator will be higher than the amount of output of the permanent magnets.
Exactly, this is the idea. The permanent magnet here, شباب, or the generated power here is very, very small compared to the converted power from mechanical to electrical. Let me give you example in numbers. If we said generator of 300 megavolt ampere, you may find the field circuits here, all of these devices up till this part, in several kilowatts. Very small amount compared to the converted power from synchronous generator. Okay, so the matter is not only converting DC to AC or using permanent magnet. No, the matter, all of these devices are considered as co-devices that helps to establish the flux. However, the main power will be converted from mechanical prime mover to the electrical power coming from the synchronous generator. Is it clear, Shabab? Is the idea clear now?
Can you repeat the last part?
Again, regarding the comparison between the power level of excitation and the power level of the synchronous machine. The question was, it's just question to make brainstorming يا شباب together. The question was, we generated three-phase AC. Why not taking this three-phase AC instead of making all of these steps in order to get three-phase AC as well? The right answer that your colleague has said, the power level is different. This is right. Again, all of these parts here, the power level is very, very small. In numbers, we can say this is several kilowatts, 5, 10 kilowatt, for instance. However, the power which is coming from the synchronous generator can be 300 megawatt, 400 megawatt, sorry, a megavolt ampere. It's a very huge amount of power, okay? Because the source of power, يا شباب, is not these parts. The source of power is the mechanical power which is coming from the turbine. All of these parts, only we call it as co-energy. Co-energy, which means it makes only excitation, makes field in order to convert the mechanical power of turbine into electrical power of a synchronous generator, which will be delivered from here. Is it clear now, Shabab? Is the idea clear?
Doctor,
تفضل.
sorry for interrupting, but you said it before, but I didn't remember how you get the power without the brushes, or how we connect between the stator and brush.
Now, we could convert here, for instance, start from the beginning. Here we have permanent magnets. And these permanent magnets are installed or fixed on a rotor, which is already moving. So we have here some coils. By rotating these permanent magnets, it will generate EMF here. Is it right?
Yes.
Okay, good. Then we convert this AC to DC to supply another machine, which is the exciter. This is stator now, okay? And this stator will produce flux, okay? And this flux will cut the machine winding here. So we will have also another EMF here. Is it right?
Yes.
This EMF can be converted from AC to DC by means of rectifier. So we now could connect DC supply to this part. صح كده? Is it clear?
Yes.
Now, did we use any brushes here in the system?
No.
So for that we call it brushless excitation. You got it?
Yes, clear. Thank you.
Yeah. Okay. Welcome. تمام يا شباب? Is it clear now?
Okay, doctor. Why you don't call it the induction machine?
Which part?
This machine. We said it
You
is
mean
synchronous.
machine?
Yes.
لا, it's different. We will say now. We will see why the name, why we call it synchronous. We will discuss it in the next slide. Okay. طيب. This exciter, شباب, is made by many companies. Lots of companies are producing exciters with many shapes. طبعا later إن شاء الله we will discuss the stability of synchronous machine, and we will discuss in more details what is needed in the exciter. Exactly, it's not only producing DC, because it's used also to control something in the machine operation. Later إن شاء الله, while discussing in more details in synchronous generator, we will return back again to the exciter in something called AVR system. Okay. Right. For now, synchronous machine. Why it's called synchronous? The name is synchronous. Why? Synchronous means there is a timing between two things. There is timing between two different things. What are these two different things now? The two different things are frequency and speed. So the frequency of the supply is in coordination with the speed of the machine. It's directly proportional. If the frequency increases, the speed will increase. If the frequency decreases, the speed will be decreased. And there is no something added or subtracted from this factor. So as you can see, according to the applied frequency, the machine speed will be. For that, we call it as synchronous machine, because the rotor is rotating in synchronized or in synchronization with the supply frequency. For that, we call it synchronous machine. In induction machine, it's different. And why it's named induction machine, inshallah, in the induction machine topics, we will discuss it in more details. Tamam? So we have here, this is our relation. NS is the synchronous speed. F is the supply frequency. And 120 over B is the ratio used to get the exact value of speed according to the applied frequency. تمام يا شباب؟ number طبعا P is the number of poles of the machine. What about the EMF? EMF generated in the machine is AC excitation. And you know the relation of AC excitation, يعني you know from previous courses in electromagnetic or electrical engineering course, the relation is 4.44, which is, as I remember, pi multiplied by square root of 2, I believe, multiplied by frequency, multiplied by flux, multiplied by number of turns of windings, number of turns per pole, multiplied by winding factor. So the main part which we need here to recognize that the induced voltage is proportional to F multiplied by phi. These are the variables now. Flux, which will be controlled by means of excitation, and the frequency, which will be according to the speed value. So these are the main parts which are depending, or which the EMF is depending now. Frequency and flux. N is number of turns of the machine, it's fixed. Kw is the winding factor, and it's also fixed according to the way of windings and dimensions of the machine. Okay, so this is the relation between EMF and the flux. For that, Shabab, the magnetization curve of any machine is like that. When you increase the field current, the flux will increase up till reaching to saturation. The same is also here. The relation between IF and EF at certain speed. At certain speed, because as we discussed, E is proportional to F multiplied by flux. And the field current here representing flux. Okay? So IF at certain frequency will have the same shape as the magnetization curve of E. Okay? However, if you change the omega, you will have another curve. Okay, Shabab? Fine. So this is called magnetization curve, and this is the relation between EMF and supplying currents. Now, for the rotating magnetic field, we agreed together, Shabab, that the magnetic field of the three-phase is rotating. يعني, I know you already learned this derivation before, so it's not very important for us. What we need, if you just start from the beginning, the knowledge of current for the three phases, and you know MMF equals N multiplied by I by cosine theta. So if you substitute the relations of currents here, three-phase currents in the EMF, finally you will get this part which is N I maximum cosine omega t minus theta plus half N I maximum cosine omega t plus theta. We can classify into different parts. طبعا we have here at angle 0, angle minus 240 plus 240. So we can classify now the MMF in two parts. One part which is constant. As you can see, these terms are three identical terms, and these terms are shifted by 120 degrees. مظبوط كده يا شباب؟ Here at 0 angle, here minus 240, here plus 240 or minus 120. So if you summate these three terms, which are representing the backward flux, it will be 0. However, the summation of this part will be 3 over 2 N I maximum cosine omega t minus theta. Just for the function now of F or magnetomotive force just being cosine wave, this means the flux is rotating. And this is يا شباب the reason of having motion for any AC machines. No AC machine will work without rotating flux. Okay. For the power flow of a synchronous machine, we can have either generator or motor. For generator, طبعا generator is supplied by mechanical power by means of prime mover. So we have input mechanical power, torque multiplied by omega, and we will have some internal losses of the machine, like stray losses, like friction and windage losses, like core losses, and we have converted power. This converted power, which is traveling from stator to rotor, or rotor to stator here as a generator. Then we will have some copper losses in the armature windings, and the remainder power will be the AC power, which can be represented as square root of 3 V line I line cosine theta, where theta is the power factor angle, or cosine theta is the power factor. This is a general form of active power obtained from generator. If it is motor يا شباب, as you can see, the power will be reversed. So you will have supply in the stator side, which is 3. طبعا معلش يعني sorry يا شباب, here it's written as a line, here it's written as a phase. So 3 V terminal here is phase. Okay, you have to recognize that يعني either 3 phase, 3 V phase, or square root of 3 V line. Okay, I phase cosine theta. This is the input electrical power, and we have some losses, I square R losses, which is copper. We have core, we have mechanical, we have stray, and the remainder power also will be the mechanical power of the motor. Okay, so as you could see here, the power flow is يعني reversed. The same machine can operate as a motor or generator according to the power flow. And I believe it's enough for today's class. I will stop recording now, and if you have any question, you are welcome. Any question يا شباب؟